Hello once more, CP Finitians, and here is 7.3 Conditional Probability. The terminology for today is the word given. Given. I'm going to be giving you some extra information, and whenever you see that word, that tells you basically that you can narrow down your probability, okay? Now here is the formula. You're like, oh my gosh, this is where it gets real. But really, it's not too hard, okay? What this thing means is the probability of event E given, there's the word, event F almost has occurred. So that little bar is just the given bar. It just means given. Alrighty? And basically what you're going to do is you're going to be taking the intersection of the two events over the probability of the given event. You're like, what in the world? But it's going to be okay, okay? For the example, let's consider the scenario. A 3-children family can consist of boys and girls, obviously, okay? Providing the sample space. So maybe the oldest child is a boy, followed by a boy, and followed by a boy. So maybe it's boy, boy, boy. Maybe it's boy, boy, girl. Maybe it's boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. Girl, girl, girl. Okay? Just to kind of help us out, I will highlight the different boy and girls. Okay, so think of the first letter as being the oldest child, middle child, and so forth, okay? Let's let event E be the selection of either boy, boy, girl, girl, boy, girl, or girl, boy, boy. Again, I will be giving you the events. Now, as you go through, it's kind of a good idea to kind of think of the different probabilities, but we'll keep going here. Let event F be the selection of boy, 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 girl, boy, girl, boy, boy, girl, boy. Like, oh my, what is going on? Okay, it says determine the probability of E given F. That means all it wants you to do is find probability of E such that F has occurred. Okay, so basically using the formula. Determine how many elements are shared. So how many things are in E and F? Okay, well let's look at the two of them. How many of the events between these two pieces are shared? Well, I see boy, boy, girl is shared, so there's 1. I see boy, girl, boy is shared, there's 2, and that's it. So they share boy, boy, girl, girl, boy, girl. And the number of elements in F is, okay, there are 4 possibilities in F, so this is 2 possibilities. There's 2. The number of things in F are 4, okay? And really here all it is, it's the probability at the top, so the probability of the intersection, okay? We say that is 2 out of, really it's 2 out of all the events, so 1, 2, 3, 4, 5, 6, 7, 8. Divided by the probability of F, well that was 4 out of 8. And here's the little trick, is when you divide fractions, it's 2 over 8, you keep, flip, change the multiplication, 8 over 4, and really it's 2 over 4, or 1/2. Some of you might be able to notice this right off the bat, okay? Because really, you don't need the denominator, okay? You could have simply had 2 over 4 and said, hey, it's 1/2. Really, it's just asking, if I give you these elements, what's the probability of getting these 2? It would have been 2 out of 4. So it's like I'm narrowing down the sample with the given. Okay? Still kind of lost is no problem. Let's look here. Suppose E and F are events of a sample space S, from which the probability of E is 0.7, F is 0.8, and they tell you the probability of the intersection. Find E given F. Well, using the formula, that means the intersection is up top. Well, that's 0.6. F is down below. Well, that's 0.8. 0.6 over 0.8. Let me get my calculator. Is 0.75 or 75%. The little difference here, probability of F given E, well, this is still the same. Okay, the intersection is still the same. F and E is the same thing as E and F, so it's still 0.6. The only thing that's different is that this second piece is always the one that's down below. So probability of E now, E is 0.7. So you have 0.6 divided by 0.7. And that's a nasty fraction, ends up being 6/7, just nothing really too fancy. 6/7 or 0.857, that's an 8. Blah, 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 blah. Okay, I would accept 6/7. So really, it's just the intersection over the given probability. Okay, what this can also be examined in are tables. So using our table from before, let E be the event of selecting a male Flyers fan. Okay, F is selecting a male in general. G is selecting a female Penguins fan. H is selecting a Penguins fan. So I want the probability of E given F. If I put that in words, it's probability of selecting a male Flyer given that I pick a male. Okay, so really, all I'm looking at are the males, so the men. Okay, there's a total of 800 men. And of the Flyers, of them, I just want the Flyers fans. So really, it's just 300 over 800. There are 300 male Flyers fans over the 800, so 300 over 800. Word problems you can kind of get away with, not so much using the formula, but just kind of analyzing what it's saying. G given H, so female Penguin fan, given that I select a Penguins fan. So given Penguins fan. Well, now I'm just looking at the Penguins fans. We'll say this is in green. Well, there are 1050 of them. And I want to know which one are the females. Well, there are 550. So 550 over 1050. Okay, 550 over 1050. We're looking at a big old 1121s. 11 over 21. Okay. F given E. Okay, what that means, so that is probability of a male given I select a male Flyers fan. Well, let's see here. What is going on here? Well, E is the male Flyers fan, so I know that how many of them are there? There are 300. Okay. And, or if I select a male, there are, so given it's a male Flyer fan, yes, there are 300. And now, given that I select a male Flyers fan, what's the probability of them being male? If I selected a male, they're going to have to be a male. So that's 100%. Okay. So sometimes they're a little silly like that. It's telling you, hey, I selected event E, which is a male Flyers fan. So I'm already here. What is the probability that they're a guy? Well, if they're a male Flyers fan, they hopefully are a guy. Okay. H given G. Let's see here. This one's a little different. So now I have what is the probability of a Pens fan given that they are a female Penguins fan. And again, it's kind of counterintuitive or inductive that, well, if I select a female Pens fan, that means I already selected a 550. And foremost, if they're a female Pens fan, then they're already a Pens fan. So those ones there are kind of silly in that they end up being the same or 100%, but really the ones to focus on are the ones like A and C. Okay, so what I would like you to do for the essential question is kind of a 2-for-1 deal here. So one, I would like you to write out, and we're going to use the same events from above, write out what the probability, so probability of, if I were to say H, this thing F, I want to know what that translates to. Okay. And I want you to find that probability. So find that probability. Okay. And also 3, why not something fun? I always like to have something fun. Any type of condition. Okay, first thing that comes to mind when I say condition, try and keep them appropriate, of course. So maybe you have some sort of condition, maybe it's hair conditioner, maybe it's the air conditioner, I don't know, any type of condition, funny thing, make it fun, exciting, okay? 1 and 2, 1, convert that into words, 2, find the probability, 3, give me some sort of condition. And thanks guys, as always, see you later.